Hello, my name is Dino Veland, and today I'll be taking you on a tour of Python tools for Visual Studio. We'll be looking at both existing functionality as well as new features introduced in the 2.0 release. First, let's get started with the new installation experience in Visual Studio 2013. I can now go to File, New Project, and you can see under other languages we now have Python as an option. And we have Get Python Tools for Visual Studio right here as our one project template. I'm just going to go ahead and click OK. And you can see we bring you to a window where you can download PTVS. I'll go ahead and click on Download, click on Run, accept the license agreement, and shut down Visual Studio. Click Install. Now that I'm back in Visual Studio, I can once again go to File, New Project. And you can see instead of having the Install Python Tools for Visual Studio link, I now have a number of different project types that I can select. So I'm going to go ahead and get started here with a simple Python application. So here we are in my new project. If you're a typical Visual Studio user, this should look pretty familiar to you. On the right-hand side, I have Solution Explorer, where I have the files that are in my project, and on the left-hand side, I have the main file of my application. The first thing that I'm going to go ahead and try to do is run my application. So I'll click on Start. And we get this nice helpful window explaining that we didn't find any Python interpreters. Python Tools for Visual Studio works with any Python interpreter that you'd like, and so you can use CPython, which is the standard Python interpreter, IronPython, or you can get something like PyPy or Jython as well. Here we have a simple link that will download and install the latest version of CPython, which is the most commonly used implementation. So I'll go ahead and click on that and install Python. So here I get the Run dialog for Python 3.3.2. I'll go ahead and click Run. Next, I'm going to go ahead and bring up the Environments window, which is a new feature in PTVS 2.0. Here you can see all of the Python interpreters that I have installed. I can bring up an interactive window. I can bring up various options for these interpreters. And you can see that we've already started analyzing the standard library in the background. This will be used to provide Intellisense completions against all of the packages installed for this interpreter. One of the nice features of Python is the REPL window, or the Read Eval Print loop. I can go ahead and open this by clicking on Interactive window here, and I can immediately start writing some code such as print 42, 2 plus 2, or even more complicated function definitions. You can see we give signature help and IntelliSense inside of the REPL, and I can quickly play around and discover what I want to do with Python code. You may already be used to using the REPL from the command line, but one of the nice things about using it inside of Visual Studio is the improved features that we have. So for example, in addition to normal history, we have multi-line history. So I can go back and I can edit my function here. I can go ahead and change the name. I can change what it's going to output and update it in line and go ahead and call the new function, and I didn't have to go through and recreate each individual line of that function. So this makes it a really productive environment when you compare it to the base command line experience. Another key feature of the REPL is its ability to support IPython. Here I've reconfigured the windows so that I have my application code on the left-hand side and the REPL window over on the right. And as you can see from the prompt, this is an IPython session. PTVS also includes some commands that let you quickly send code from the editor window into the REPL. So here I can come in and select all of the code in the editor window, right-click, and do Send to Interactive. This is going to take the code, send it over the interactive window, and you can see I get a nice inline plot. I can go ahead and resize it if I want to see a bigger view of it, or I can go ahead and shrink it down when I'm done with it. But the real power of PTVS is in the editing experience, so let's go ahead and switch over to that. I'll go ahead and close the interactive window. We can see here in the environments now that my completion database is all up to date, and so that means I'll get live completions against the standard library. So we can go ahead and close this dialog as well. So here I'm back in the editor window, and one of the first things that I want to do is go ahead and import a module so that I can start working against it. After I type import space, you can see I get a list of completions. I can go ahead and look through all of the different modules that are part of the standard library, and you can see I get nice descriptions of what those different modules are. I can also go ahead and type in substrings or just a couple of letters out of the module that I'm looking for. So here I typed AG, and you can see we filtered down to anti-gravity and some other modules that are containing both the letters A and G. This is a new feature in 2.0. We also support random substrings so that you can quickly figure out what you are looking for, even if you're not sure exactly what it's called. If you used PTVS before, you're already used to our great Intellisense experience. So for example, I can go ahead and declare a class here and declare a method in it, a constructor, that's going to go ahead and assign an attribute into it. I can then go ahead and construct an instance of this class, and you can see we provide signature help along the way for the constructor, and I can then go ahead, dot through. We understand that there's a value attribute, and I can even dot through that, and we understand that that value attribute is an integer, and of course it has all of the integer methods on it. I can also hover and get quick information, and you can see that we know that value is an int, and of course I can go ahead and change what my code's doing, and we'll now see that value's there, and it's a string. And so as you go through and modify your program, we are constantly updating our understanding of the code and giving you a really great code completion experience as you go along. And of course, if I were to go again and add a second call to this and look at value, we'll even show you that this could be an integer or a string, and we'll give you completions and inform you where those completions are coming from so that you can reason about what exactly you can call, what would be legal, what wouldn't work, and so on. But that hasn't really changed in 2.0, but we have made many improvements to the code intelligence. And one of the areas that we've improved significantly is around decorators, where we now model your code much more accurately. So I can come in here and write a decorator, and I'm going to go ahead and define an inner function called adder here that takes an argument. And it's going to return the decorated function plus the value that it's passed, and my decorator is going to return adder. Next, I'm going to go ahead and use my decorator and define a new function that doesn't take any arguments and just returns a simple integer value. So now I can go ahead and call my G function, and you can see immediately that we recognize that I'm actually calling adder. And I can go ahead and pass in an argument, which I'll pass in 100, and now we know that the result that's coming back from that is actually an integer. So I'm getting all of my integer completions here, and if I were to hover on A, you can see that we know its type is int. Next, I'm going to go ahead and call this with a floating point value. So here you can see that we now know that the result of calling that is a float. But if I go ahead and hover on A, we still know that that's an int. So we're actually modeling these two calls completely independently each other and going through and understanding all of the decorators and how all of this flows around. And so this will give you a much better completion experience when you're working with large real-world Python projects. Another way we've improved Intellisense in 2.0 is by improving our understanding of C extension modules. Here I have a simple PyQt app, and you can see I've created an application and a button, and I'm going to go ahead and add a call to show that button. And as you can see, as I dot through that, we give you great completions for all of the members that are available on button. And if I go ahead and do an open paren, we'll give you signature help. Likewise, if I were to go to app and go to, say, find children, we can see there we give signature help, we have different information about the arguments, and I can look at the different overloads that we believe are actually there based upon the arguments from the doc string. While you spend a lot of time writing Python code, you probably spend more time actually reading code. Whether that's code that you've written or whether that's code that someone else has written, it's always useful to have good tools to help you navigate that code. So here I'm looking at beautifulsoup, which is a library written in Python for parsing XML or HTML documents. I don't know much about this library, but I want to dig into it and understand it a little bit more. And so one of the first things I'm going to do is look at how it removes nodes. So here I can see that I have a extract method, and that's being used when I'm replacing a node with another node. And so I want to understand this a little bit more. So I'm going to just right click on it and choose Go to Definition. And you can see I quickly jump to the function, and I can go ahead, read the code, figure out what's going on. But I'm kind of curious where other places this is being called from. So the next thing I do is right click on it and do Find All References. And you can see we have the definition here, and I can also jump to all of the different callers. So I can understand what this is being used by, and where it's being used, and in what context it's being used. And so that can quickly let me jump both from the callers and the function that's being called and figure out how exactly it works. But Python code can be chained together in all sorts of interesting ways. And one of those ways is by passing around functions as first-class members. So here you can see we have a findNext method in beautifulsoup, and it's actually passing in this findAllNext method here to a findOne method. So we have a helper function, and that function is actually being passed another function which is going to be called. So I can go to the helper function, and I can see that it's being passed the method that's it's calling the method that's being passed in here, and I want to understand more about where findOne's being used. So what I'm actually going to do is do findAllReferences on method. And the really cool thing here is that I get not only the definitions where method is defined, I get the reference to it where it's actually being invoked, but you can actually see the values of the functions being passed in. So I can really start to reason about what this findOne method is doing, who's using it, and how they're using it. In PTVS 2.0, we've introduced another way to explore your code, which is the navigate to command. So I can go to Edit, Navigate to, or I can use the key binding, which in my case is Control comma. So I hit Control comma, and you can see that Visual Studio brings up the inline search dialog. I'll go ahead and type soup, and you can see I instantly get a list of results here. So I have beautiful stone soup, I can't believe it's beautiful soup, or minimal soup. So I can quickly find things in my project at the class level and jump to them. So here I jump to minimal soup, and I can start reading the doc string and figure out what it's about. We've also made a number of improvements to the project system in 2.0, including virtual support, show all files, and a large number of performance improvements and bug fixes. To demonstrate some of these, I'm going to go ahead and use a Django application. So I'll do File, New Project, and you can see I have the various options here, and I'm going to go ahead and choose Django Project to get started. So the first differences in Solution Explorer that you might notice is the addition of the Python Environments tab. I go ahead and right click on that, and you can see I have a number of operations that I can perform. I can add or remove an existing Python environment, I can add a virtual environment, or I can add an existing virtual environment. And today I'm just going to go ahead and add a virtual environment. You can see it lets me choose a name, it lets me choose which interpreter I'm going to go ahead and base the virtual environment upon, and I'm just going to choose Python 2.7. You'll also see that I need to go ahead and install pip and virtualenv, which will be installed for me into my base Python installation, and then the virtual environment will be created. So I'm going to go ahead and press Create now, and you can see we get the status along the way. And once the virtual environment is successfully created, it's displayed under the Python Environments tab inside of Solution Explorer. So next, I'm going to go ahead and install a package into my virtual environment. And because I'm working with a Django project, that package is actually going to be Django. So I just go ahead and right-click on the environment, choose Install Python Package, and type the name. I have a number of options here. I can either use pip or easy install, and if I need to, I can elevate. But I'll just go ahead and install Django using pip. So you can now see in the output window that Django was successfully installed, and if I go and look inside of my environment, inside of Solution Explorer, you can see that we also list that Django is installed there as well. So now that I've created my virtual environment and installed Django, I can actually go ahead and run my application. So I'm just going to click play here, which is going to go ahead and launch the Django development server. Here you can see from this path that we're running out of the virtual environment. And we load the web browser, and we get the Welcome to Django page. Finally, I'm going to show another new feature in PTVS 2.0, which is the ability to deploy a Django project to a Windows Azure website. So here I have my Django project. I'm just going to go ahead, right-click on it, and choose Publish. This will bring up the Publish Web dialog where I can select my Publish profile. I've previously downloaded that from the Windows Azure portal, so I'm just going to go ahead and select that file, click OK, go through the various settings. The defaults are fine. And I'll get here and click Publish and send my site up to Windows Azure. So you can see it's just that easy to get a site up and running in the cloud. All I had to do was create a new project, install Django into my new virtual in that project, and right-click Publish, and there we are. The next step for my Django project is to add an application to it. So I can right-click on the project, go to Add, and choose Django App. And I'll just go ahead and give it a name. As you can see, my app is created, complete with my views, tests, and models, and a base template. Next, I need to let Django know about the app that I've just created. So I'll go ahead and open settings.py, search for installed apps, and go ahead and add my app to the list of installed apps. From here, I need to go ahead and add an Earl Handler, and so I'll just add one for the root by updating this existing one. And we'll go ahead and point at the home method inside of my views file. Let's go and have a look at that template now. And we can see it's just a blank HTML file which is going to show my content. So let's go ahead and implement that handler now. So I'm going to open my views file, and I'm going to add a new method called home, which is going to take the request object, and it's going to return an HTTP response. And I'm just going to go ahead and do a render to string to render my template out, and we'll give it some content that it can work with. So now I can go ahead and press F5 to run my application. And we'll see again Django launches, and the web browser launches, and you can see I'm actually rendering out my content here. So now it's time for me to work on my template, and rather than just rendering out that content, I'm going to switch over to my HTML file here. And change this so that I'm rendering each individual item one by one. Finally, I'm going to go ahead and set a breakpoint here on item, and go ahead and again launch in the web browser. We can see my Django app starts again, web browser opens, and we break into the debugger where I can go ahead and inspect and see what's going on. We can see here the item has a value of 1. I can hover and see content, expand it. I can even step and see an item updated to its new value. So this shows the power of Django template debugging inside of PTVS. Another new feature in this release is the Format Code command. This lets you quickly update your codes that matches the style guides that you've previously defined inside of Visual Studio. So I can go to Edit, Advanced, Format Document, and you can also see there's a format selection which just updates the selected code. I'm going to go ahead and do Format Document. So you can see from the change bars on the left-hand side that we just updated a couple of lines. And all that's really happened here is we've inserted some spaces where we didn't have them between binary operators. There's lots of options that you can control about how code is formatted. You can access those through Tools, Options, Text Editor, Python, Formatting. There you'll find spacing, various options about statements, and even how comments are wrapped when code is reformatted. We've also made a number of improvements to debugging in PTVS 2.0, including debugging standalone scripts, remote debugging, and mixed mode debugging. Debugging standalone scripts lets you quickly debug a script which isn't inside of a project or solution, or it lets you quickly switch between the script that you want to debug when you are working inside of a project or solution. Here I simply have a file open, and I have nothing active in Solution Explorer, as you can see. I can come in here and I can set a breakpoint on this first line, and I can right click on the file name. And here I have two new options, Start with Debugging and Start without Debugging. So I'm going to go ahead and choose Start with Debugging. And you can see my Python interpreter launches, my script's running, I break in, and I'm debugging. And it's as simple as that. We also have a new feature for debugging processes running on a remote machine. It doesn't matter whether that machine's running Windows or Mac OS X or Linux, we can debug it as long as you have a Python interpreter that's running there. To get started with this feature, we'll go to the Debug menu and choose Attach to Process. From here you can see that there's a couple of new options under Transport, Python Remote Debugging SSL and Python Remote Debugging Unsecured. I'm going to go ahead and choose unsecured because I'm just connecting over the local internet and I'm not concerned about encrypting the connection. So next I'm going to go ahead and type in a secret password that I've set up in my script and give it the machine name that I'm going to go ahead and connect to, and then press enter. You'll see we go off, connect to the remote machine, and find the process that's running there, and I can go ahead and choose attach at this point. Visual Studio goes ahead and prompts me to find the source code, which is over on my remote machine, so I'll just go ahead and navigate to the share there and open that file. And you can see we immediately break in and we have the exception reported that just occurred. From here you can also see what it takes to set up the remote debugging from the script side of things. Here we have an import PTVSD, PTVSD enable attach with my secret password, and then the wait for attach call, which just blocks the process until the debugger is actually set up and running. Another major feature in this release is mixed mode debugging. Mixed mode debugging lets you debug both your C++ code and your Python code at the same time. You can set breakpoints in either Python or C++. You can step from C++ code that calls into Python or vice versa. To demo this feature, I have a solution that's set up with both a Python application as well as a C++ extension module. If I go to the project properties for the Python application, you'll see under Debug that there's an Enable Native Code Debugging checkbox, and I have that selected. To get started, I'm just going to go ahead and start debugging. You notice we launch the Python interpreter, and the first thing my program does is waits for some input. So I'll go ahead and continue, and you can see we immediately hit this breakpoint inside of my Python code. But the truly interesting thing is over here in the call stack, where you can see we have not only Python code on the call stack, but we also have some C code, and that's just the normal startup code. So I'm going to go ahead and continue running. And we hit this other breakpoint in my program. And here I have a module, which is actually a C extension module, and I'm going to go ahead and call a method on it, and I'm going to actually pass in a Python function object to that method. So let's go ahead and step into this function call. You'll notice that we immediately step into a C function, and that function is going to go ahead and turn around and call that argument that we passed in. Inside of here I can start drilling into my individual objects. So you can see I have the normal C API view of the objects, but I can also go ahead and switch to this Python view and quickly see what this object would look like from pure Python code. I can go ahead and step in again, and you can see that once again we've stepped from C++ to Python code. And you can see that as I've been doing this, my call stack's growing, and I have both my C extension on the call stack as well as my Python code that's calling into the C extension. And finally, we even have the Python code that the C extension called back into. So you can see this is an extremely powerful feature that lets you see both sides of the world when you're working on a C extension module and Python code at the same time. We hope this will greatly simplify your development experience whenever you're writing some C extension modules. Another new feature introduced in this release is unit test support. Here you can see I have a project that's open, and inside of it I have a couple of test cases written using unit test. Over on the left-hand side, you can see that I have Test Explorer open, and it's discovered all of the tests inside of my project. To run the tests, I can just come over and click on Run All here, and it's going to go through and run all of the tests that it knows about. Not too surprisingly, one of those tests failed, so I'd like to go ahead and debug it. One way I can go about doing that is just going into the source file here, right-clicking, and choosing either Run Tests or Debug Tests. Because I want to debug it, I'll choose Debug Test. You'll see we'll go ahead, we'll launch the test case under the debugger, and we'll go ahead and break at the breakpoint that I've just set. From here, I can drill into what's going on. I can step through my test case and figure out why it's not working anymore. Another useful feature for understanding your code is our built-in profiling support. To get started with this, you can go to the Analyze menu and choose Launch Python Profiling. Here I have a project that's already open that includes Pystone, one of the standard benchmarks shipped with every version of Python. I could also choose to launch a standalone script and choose which interpreter I want to run with it and set up various startup options. But today I'm just going to go ahead and profile my project. I'll go ahead and click Start. And you can see that Pystone ran and completes. I'll press Enter and let that close. And inside of Visual Studio, we open the performance report. The first thing that you'll notice is in the summary view, we have the hot path, which is the call stacks where we're spending most of the time. I can go ahead and click on one of those functions, and we'll be switched to this nice view where I can see both the calling functions, as well as the functions being called, and the relative amount of time being spent inside of each of those functions. I also get the source code below so I can quickly see what's going on. I can also quickly switch between different views, and my favorite view here is the caller-callee view, so I'll go ahead and click on that. And this is a little more of a table-oriented form of what we were just looking at, but the nice thing here is I can go ahead and start sorting by elapsed inclusive time, exclusive time, and quickly drill into the biggest things where we're spending our time. I can bounce between the various functions, going up and down the call stack, and quickly understand where all of my time is being consumed. Thanks for taking the time to watch this overview of Python tools for Visual Studio 2.0. I hope you found it useful. If you'd like to know more information about individual features, we have other videos and documentation on our Codeplex site, pytools.codeplex.com.